Recreating the moon's surface. This is the Sea of Tranquility, the very spot where humans first set foot on the moon. And this is Arizona. At a glance, if these images weren't labeled, you'd hardly be able to tell them apart. Every crater matches perfectly in size and position. This isn't some bizarre hoax, nor a natural phenomenon. NASA meticulously crafted this landscape to replicate the moon's surface. Using explosives, a seemingly ordinary field in Arizona was instantly transformed into the most moon-like place on Earth. Today, many of these craters have been reclaimed by nature. Why NASA recreated the moon's surface? In the late 1960s, as NASA prepared for humanity's first lunar landing, a pressing question loomed: what exactly would astronauts do once they got there? Back then, knowledge about the moon's formation and surface composition was limited. The best images available were from lunar orbiter satellites, with a resolution of only about 2 meters. These images revealed only the largest craters, leaving finer surface details a mystery. NASA understood that studying the moon's rocks, craters, and materials could unlock secrets about the origins of both the moon and Earth. But astronauts had very limited time on the lunar surface, so maximizing scientific output from each mission was critical. That's where Cinder Lake came in. What is the Cinder Lake crater field? Before stepping onto the moon, astronauts needed to become geology experts, able to glance at a crater and estimate its age, and to describe lunar rocks and materials with precision. NASA set out to recreate the moon's surface right here, in a field near Flagstaff, Arizona. Situated near an extinct volcano, this field was naturally covered in volcanic gravel, similar to lunar soil. However, building a 1-to-1 scale model of the Apollo landing site was no simple feat. How NASA recreated the Apollo landing site? To sculpt this terrain, NASA used, you guessed it, dynamite. Their goal was not only to match the exact size and placement of each crater, but also to replicate their relative ages. Using lunar orbiter photos, NASA applied the principle of superposition. Younger craters overlay older ones, with newer impacts partially destroying older crater rims. For example, a large crater formed first, followed by smaller craters inside or overlapping it. The team marked all 143 craters, categorizing them as new, intermediate, or old. They then placed precise amounts of dynamite at each location and detonated them sequentially, oldest craters first, moving toward the newest. The transformation was astonishing. An ordinary Arizona field became a near-perfect replica of the Apollo 11 landing site in an instant. How NASA used this site? One early challenge for astronauts was figuring out their exact landing location. Although NASA targeted a landing zone, the actual touchdown point could vary within a 5-kilometer radius. Without knowing their position, astronauts couldn't navigate to interesting craters or report their explorations accurately. NASA posed the question: could astronauts pinpoint their location by comparing their view from the lunar module with a map of the surface? This is where Cinder Lake proved invaluable. A mock lunar module was placed randomly in the crater field, and 28 test subjects, including geologists, mathematicians, and surveyors, were each given 30 minutes inside to determine their location. Although seeing the geography from above makes orientation easier, identifying landmarks on the ground is much tougher. The moon's lack of atmosphere means distant objects lack the usual haze, causing large rocks far away to look like smaller, nearby ones. NASA hoped the tests would reveal the most effective navigation techniques. Each participant was given a real satellite image of the moon and 30 minutes to mark their guessed location. If unsuccessful, they received progressively smaller maps zooming in from 1 kilometer down to just 1/64th of a kilometer. After 4 hours, failure to locate their position meant failing the test. Test results and best strategies. Out of 28 participants, 6 located their position using the 1-kilometer map. 12 succeeded with the second map, 8 with the third, 1 with the fourth, and 1 failed the test. Interestingly, the most successful navigation method was searching for pairs of craters. While lines or groups of craters might seem easier to spot, none of the test subjects succeeded with those strategies initially. Those who started with lines eventually switched to pairs. Remembering the shape of two craters proved simpler than visualizing complex patterns. NASA concluded that with further training and familiarity, astronauts would reliably locate themselves on the lunar surface. Training and scientific exploration at Cinder Lake. On the Moon, astronauts would be the eyes and hands of Earth-bound scientists, exploring a world untouched by humans. At Cinder Lake, geologists trained astronauts to identify specific rocks and collect samples, practicing radio communication with scientists back on Earth. However, NASA soon realized that radio alone wasn't enough to fully understand astronaut activity and location. This led to experimenting with live video transmission from Cinder Lake, a breakthrough that facilitated better collaboration and led NASA to broadcast live during every lunar mission. Astronauts trained here until the Apollo program ended, and over 6 missions, they returned with more than 380 kilograms of lunar samples from 6 distinct locations. Each sample was carefully preserved, allowing scientists to study pristine lunar material to this day. All of this incredible scientific progress owes a debt to this small field in Arizona.